Okay, Waka, so in activity 4.4, combining transformations of absolute value functions. When a function is transformed by changing the a or d values of both, these changes are said to occur outside the function. These values affect the output to a function y when the b or c values are changed. This changes the argument of the function. A change to the argument of a function is said to happen inside the function. These values affect the input to a function x. Go ahead and look at outside the function and inside the function. Go ahead and mark out number 1. Let's take a look at 2. Given the basic absolute value function f of x equals the absolute value of x, consider each transformation. Describe how the transformations affected f of x. Then use coordinate notation to describe how each point x, y on the graph of f of x becomes a point on the graph of the transformation function. Finally, sketch a graph of each new function. All right, let's take a look at the next page. Describe the transformations. 2a. We have m of x equals 2 times f of x minus 1. So we want to remember that f of x is the absolute value of x. So we can rewrite m of x equals 2 times f of x minus 1 as 2 times the absolute value of x minus 1. All right, let's go ahead and graph that in Desmos. So I'm going to come over here. I'm going to do m of x equals 2 times the absolute value of x minus 1. Alright, let's go ahead and grab some points. So we have 1, 0, 0, 2, and 2, 2. Okay, so let's go ahead and graph those points. So 0, 2, 1, 0, and 2, 2. All right, and we're going to graph this in blue. All right, so that's a vertical stretch by 2 units, translated right 1 unit. All right, let's take a look at 2b. So we can write r of x equals 1/2 f of x plus 2 minus 2 as 1/2 times the absolute value of x plus 2 minus 2. All right, let's go ahead and graph that in Desmos. So I'm going to remove this one. And then that's r of x equals 1 divided by 2, parentheses, absolute value of x plus 2 minus 2. Alright, so let's get some points. We can use 2, -2, -6, 0, and 2, 0. Alright, so we have -1, 2, 3, 4, 5, 6, 0, -2, -2, and 1, 2, 0. Alright, so let's go ahead and graph that in green. Alright. And we can see it's a vertical compression by 1/2 units. It's translated left 2 units and translated down 2 units. All right, go ahead and finish up 2a and 2b. Let's take a look at 2c. So w of x equals 2 times f of x plus 3 plus 1, which can be rewritten as 2 times the absolute value of x plus 3 plus 1. Let's go ahead and graph that in Desmos. So that's 2 absolute value, w of x equals 2 absolute value x plus 3 plus 1. All right, let's see if we can get our points. -3, 1 works. and negative 4, 3, and negative 2, 3. So negative 4, 3, and negative 2, 3. All right. So we have negative 3, 1, negative 4 up 1, 2, 3, and then negative 2 up 1, 2, 3. And I forgot what color that was. Purple. Let's see if it's purple. Yep, we can graph that out. All right. Right, and that's a vertical stretch by 2 units, translated left 3 units, and translated up 1 unit. All right, let's take a look at 2D. So we have v of x equals negative 2 times f of parentheses x plus 3, or I'm sorry, f of x plus 3 plus 1, which can be rewritten as negative 2 times the absolute value of x plus 3 plus 1. All right, let's go ahead and graph that in Desmos. So we have v of x equals negative 2 absolute value of x plus 3 plus 1. Let's find our points. Negative 3, 1. That's not good. Let's see if this negative 4, negative 1. And let's see if this point probably works. Negative 2, negative 1. All right, so negative 1, 2, 3, 4, negative 1. Negative 1, 2, 3, positive 1. Negative 1, 2, negative 1. And let's see what color that was. Black. Graph that in black. Right, and that's reflected across the x-axis. Vertical stretch by 2 units. Translated left 3 units. Translated up 1 unit. All right, go ahead and finish up your notes and have a wonderful Wildcat day.